since this triangle is not a right-angled triangle, we cannot use the trig ratios. So we have to employ the sine rule. The sine rule states that whenever you have a triangle, the ratios of the sine of an angle to the side opposite to that angle are always the same in a triangle. That is, the ratio of the sine of the angle A to the side opposite to it, which is small a, is the same as the ratio of sine of this angle B to the side which is opposite to the angle B, which is small b in this case, which is also the same as the ratio of the sine of the angle C to the side opposite to angle C, which is small c. This means that if we take this triangle, then the sine of the angle 35 divided by the side opposite to 35, which is 8.2, should be equal to the sine of angle X divided by the side opposite 11.9. Now we solve for the value of X, and what we do is that we multiply both sides by 11.9 so that we have 11.9 sine 35 divided by 8.2 is equal to 9x. And when you type this, you get 0.8323, which should be equal to sine x. But remember, we want to find the value of the angle x. So to do this, we take the sine inverse of this answer. So x is equal to the sine inverse of 0.8323. And when we do this, we get x to be 56.3 degrees. However, this is not the only angle that when we take sine of it, we'll get this value. And this leads us to a concept called the ambiguous case of the sine rule. You can read about that. The angle could also be 180 minus 56.3, meaning x can also be 123.7 degrees.